Thanks everyone for joining us today. As Eliza mentioned, we're going to be talking about driving productivity within the bottling industry, really primarily focusing on how technology and digitizing your machine health can really help to address your productivity and prevent machine failures by utilizing that data. In addition, we actually have a guest speaker from the bottling industry that is going to be sharing his experience with leveraging digital transformation at his organization and how that digital transformation is helping to improve operational efficiency within his bottling industry. So let's go ahead and get started today. First, I'd like to introduce a little bit about myself. I'm an account manager here at Augury, focusing on our industrial and commercial clients and their digital transformation journeys. I've worked with many of Augury's bottling customers, of course, as well as CPG and pharma. My background is within resource efficiency in the industrial and commercial environment. I have an MA in international trade, as well as a BA in international relations. I live in Northern Virginia, DC area. So it's a lovely, steamy day today. Our guest speaker today is Jaleh Kapadia. He is a senior systems reliability engineer at a leading bottling company and is helping to build a culture of reliability-centered maintenance there. He has a BE in instrumentation and control, as well as an MS in engineering and industrial management, and come to us today with over 6 years of bottling food and beverage experience. So we're really, really happy to have him. To get started today, it's really important to understand more about the industry writ large and really how technology is helping to drive productivity within the industry. And so we'd like to start out with some context around the market as a whole. So as many of you well know, artificial intelligence and digitization within the supply chain is a huge focus for manufacturing in general. The objective to reduce time to market, increase agility in your supply chains, and enhance customer experience have increased the pressure on organizations to modernize and digitize across their entire supply chain. And nowhere is this more true than, of course, within the bottling industry. So just to share some statistics around the bottling industry, first and foremost, it's a huge market, and the industry is expected to grow to $307 billion by 2024, with year-over-year growth of 9%. Within that growth, we see a couple different patterns emerging. While individual categories such as soda and some of the more sugar-based carbonated drinks may be experiencing a slight decline, there has been an explosion in new types of drinks and categories such as functional drinks, sport beverages, and other flavored sparkling drinks. And the need to adapt to these consumer preferences and these changes has never been higher. As far as dollars spent, we see a huge amount of investment in AI and digital transformation technologies in the food and beverage industry, with $650 million invested in 2018 alone. That said, the percentage of beverage CFOs saying that they are leading the competition in terms of digital transformation is only around 6%, which really shows that this investment is going to a lot of different areas, but maybe not being honed in the best way that it possibly can to maximize the impact for these organizations. And then another important factor to understand is some of the market dynamics that are impacting those investments, growth, and opportunity within the bottling industry. First, you see that the bottling market overall is extremely competitive amongst a few key suppliers. This competition increases the pressure to really differentiate themselves and create a competitive advantage on a slim margin through really driving efficiency in the manufacturing process and supply chain. With the choices of beverages for both retailers and consumers exploding and a minimal cost for the consumers to switch products, squeezing every last penny out of each of these bottles and within the supply chain is becoming more important. Consumers are also expecting an increasingly rapid time to market, the Amazon effect, as many people call it, which increases the pressure on contractual deadlines, fast turnarounds, having no lag or delays in your supply chain. This means that the reliance on working machines and having no interruptions or delays is stronger than ever. That said, of course, the bottling industry is not new to pressure for efficiency. This is obviously a pressure that has existed forever. And in the past, the bottling industry has been very focused on driving OEE, operational equipment efficiency, and total production management, and focused very much on these other efficiency standards. But they've addressed this kind of primarily through two main methods in the past. First is through really rigorous routes and preventive maintenance strategies, resulting in usually robust but sometimes burdensome and time-consuming monitoring that is based on labor and based on people. Secondly has been monitoring of production equipment through primarily OEMs and some of these equipment manufacturers who may provide data and alerts through their technology, but no real root cause analysis or trending insights into the machines. In addition, because the monitoring has been done through OEMs for the most part, not all production equipment has been monitored thoroughly. So there have been significant gaps in the coverages and the development of these siloed sources of data where, you know, the OEM has proprietary ownership of that system. And so you have a couple of different places that you're looking for data and insights into your machine health. And finally, another challenge with partnering or utilizing OEMs for this data sources is they're not as flexible and nimble to work with their customers on developing strategies to fill some of these gaps in data and coverage. This has resulted in still having some of these higher than necessary maintenance costs, still having underperforming or subpar productivity at the plant level, continued risk exposure, firefighting, and of course the dreaded unplanned downtime. And so while the bottling industry has had this focus on increasing efficiency and maintaining an efficient supply chain, there still really are a lot of machine health blind spots. And they're very costly. So $1.4 trillion, according to American Manufacturing Association, has been attributed to the fact that machine health is a blind spot. And these costs are allocated in a lot of different areas. When you look at the larger picture of an organization, there are many impacts and costs that are not traditionally correlated to machine failure, but are in fact at root tied to that pain point. Starting at the micro level, looking at the production line, we see the impacts of more of a, I guess I would call it traditional repair replacement costs and downtime. But when you get to that plant level, we see that these costs are amplified to include overall asset care optimization, including optimization around the maintenance team itself, inventory management, possibly unnecessary and costly service fees and vendor costs, contract compliance issues, and actually something that isn't talked about very often, but I know talking to others in the bottling industry is a huge pain point, and that's around employee morale at the plant level. So then these plant level costs obviously roll up to the entire organization and start to have an impact on increased risk exposure, increased openness to safety or compliance issues, and ultimately brand management around how you want to go to market with your consumers and with your customers. And at root, though, what we're seeing is that these failing machines have an impact on all of these areas. But these pain points at root can be addressed and mitigated by moving towards digitization of this machine health. And when we typically are working with our bottling customers, we see that their maintenance culture is somewhere along a spectrum or may have sort of a combination of many of these aspects that you can see in sort of the red colors. They may have some elements of reactive maintenance where they're just letting things run to failure, or they're really only reacting sort of after the fact to something happening. Some machines may be covered by obviously PMs, which we mentioned have a strong history in the bottling industry where you're setting up a time-based asset care and reporting. And maybe even you have some periodic or scattered or sporadic PDM, predictive maintenance, that provides you some insight and predictive intelligence at regular intervals, but it's not continuous or ongoing insight. But really where we see the market going and the benefits going towards in maintenance is through this digitization, through continuous monitoring, automated diagnostics. Instead of some of these more traditional methodologies, we see that organizations can move towards digital machine health and increase performance. This is really a first step in transforming your maintenance strategy. and ongoing monitoring results directly in increased uptime and optimized production outcomes. And when an organization starts to look at digitizing their machine or their maintenance strategy, it's important to consider technologies that cover both utility and production level equipment so that the data is consistent and standardized in a single repository. As I mentioned before, this was an area that historically bottling manufacturers have struggled with due to their reliance on OEMs for only monitoring a subset of the production equipment. And of course, each of these OEMs, as I mentioned, having their own proprietary systems and hardware, creating kind of a Frankenstein situation in your plant where some things are being covered by one system, some things are being covered by another. There's differences in the quality, the accuracy of the data. So it just really creates a lot of confusion and white noise at your plant. And so by covering the entire plant with a continuous monitoring strategy, organizations can ensure that the costs that we were identifying and mentioned before are truly mitigated and that the evolution to digital machine health is complete. These are just some great examples of key cost areas that we see within the bottling industry that should be a basic tenet and basic part of any kind of digital machine strategy, maintenance strategy. There are a lot of differences, as I'm sure many of you know, between glass, canning, and plastic bottling, but there are also many similarities and pain points within the industry writ large. And so addressing these both on a broad spectrum as far as covering all of the most critical cost centers, as well as some of those line efficiencies, is really critical, as well as the machines that are obviously making the plant itself run. So through digitizing both utility and production equipment, we've been able to see significant positive impact and savings with our bottling customers, and we'll go through a couple of examples of those. So overall, the benefits of digitizing can be really categorized into two main areas, through enhancing the reliability strategy at the site or in the organization, and then also enhancing the digital strategy. For most organizations that are starting to look at moving towards a digital maintenance strategy, these are it's really powerful to combine the two of these, and they are very critical to address both of these through any tactic or strategy that you guys implement. So the first, for the reliability side, there are obviously the benefits that are associated with avoiding failure, as well as optimizing asset care. And then when you're turning towards the digital side, really the benefits are mostly associated around standardization and the scalability of the technology. Both of these cannot be discounted. They're both equally important, and any strategy that we see implemented at the bottling level, it's very important to have team members and input from both sides of these in the organization. So just to give an example of what we mean when we talk about digital machine health, right? So what kind of data are we looking at here? So for in this instance, the machine health at one beer bottling company, a critical filler here was being continuously monitored. The data was then being compared to other like machines. And the data basically showed that the T51 filler was showing symptoms of bearing wear that the T52 filler clearly was not. This is some of the data, just as an example, that we're typically looking at when we say digital machine health transformation. And then what you can see here is that the maintenance manager was able to address the issue in a timely manner. They were able to make an emergency repair on the filler during a regularly scheduled downtime. The data then was able to show and measure and verify that the repair itself had a positive impact, and it was a huge win for them. That can then be aggregated at the site level with many different faults or issues being identified, where we can see that the asset had an issue. It had a severity level that was applied to it. The maintenance team was able to make an action to do something, change something, repair something, and then they were able to quantify their business aspect, the business impact at their site. So we see that this data and these digital machine health insights that we were going over before with the filler are then now applied in multiple instances to other different kinds of machines. And there's obviously additional benefits outside of just the business impact of downtime or product loss or optimized labor. You really see a lot of intangible benefits as well at the plant site. So these could be things such as increased asset life, increased uptime and throughput, inter and intra-plant collaboration. So being able to use one system and one set of data to strategize and to address in a coordinated fashion your maintenance strategy, transparency and visibility into the data, optimizing your labor, so being able to cut out maybe some of the route-based techniques or methodologies that were previously implemented, to validate the effectiveness of repairs, as we mentioned, being able to see a before and after in the data, as well as avoidance of potential safety risks. Okay, great. So now we have our industry expert that we're going to be asking some questions to, and joining us for a fireside chat is Jaleh Kapadia. Jaleh, can you hear us?
Hi, Lauren. Thank you for having me.
Hello, of course. So I'm going to ask a few different questions just about your experience with implementing a digital machine health strategy. So first question is, as you started to embark on this digital machine health journey, where have you seen the greatest impact within your organization?
So as far as a bottling industry or a bottling manufacturing facility is concerned, I would say there's like in a typical PET bottling plant, you'd see 60% of your machines are rotary, and I'd say 35% are linear, and another 5 to 10% they're static, right? So basically, the biggest impact that we see or we can potentially see in a typical bottling facility would be, of course, on all the rotary machines main drives, which are very expensive. It takes time to replace them, repair them. Very less chances that we keep them in inventory. It's the lead time to order is huge. You need the OEM to be contacted, and I guess on the bottling line, the main drives are the biggest impact creators for starting with the digital transformation journey. Along with this, I would also like to say for the utility side, and I see one of the questions being asked, for the utility side, it's the impact multiplies with the number of lines. So as you would know, we can have multiple bottling lines in a single facility which shares the utility machines, which is like compressors, chillers, cooling towers, heat exchangers. So if there's anything that could happen on the utility side, all you do is understand that every failure incident would account for your whole plant shutdown rather than just a line being down. So I would say your biggest impact is on the utilities, where you have your big expensive compressor motors, high pressure compressors, low pressure compressors, chiller motors, cooling towers, fans, and on the line side, the biggest impact you see is on the main drives of the machines. Well, that's not to say that it's like a conveyor motor. If it fails, the line goes down as well. But as compared to like other main drives, they're less critical.
Gotcha, that makes sense. One thing that you and I have talked about in the past and having a really big impact in, I was actually surprised that, I shouldn't have been, but I was surprised at how pleasantly that it was such an impact for you guys, was also the visibility into the data that really wasn't available in any kind of cohesive way before. Would you say that was also a great impact as well for the organization?
Sure. So I think like you're right on point, Lauren. So until we started this journey, we had no idea how our critical machines are doing in terms of health, right? And of course, like motors and pumps being like the standard equipment across any manufacturing industry, I guess the most critical aspect of any industry would be like, critical motors and pumps. So we did not have any visibility on how they're doing, when they were replaced last. So of course we could go back and look at our maintenance work orders, repair work orders, and see what was being done. But again, there was no formal health indication or measurement on these assets, which, it, from like what we've seen since the inception of this digitalization, is now, even if we nothing goes wrong, or we don't have an incident that was potentially saved, but we feel confident on the health of these assets, which help us plan our maintenance activities better than before.
Great. So you're currently digitally transforming certain processes within your organization. Where do you really see the next area of focus within your transformation journey?
So with the ultimate goal of having a lights out facility, which is the biggest takeaway from Industry 4.0, what we believe is this digital transformation on machine health or asset health is good. In terms of IoT on a bigger scale, how can we communicate with different business modules and share this insightful data so that we can make very educated, data-driven business decisions? So I think in the other parts of supply chain of a bottling industry, how I would see this digitalization data or the asset health data working is maybe a production department, maybe the efficiency planning and the sales planning could be affected with how well our machines are running, right? So if I would say, for example, I have a fault that 2 months down the line this machine's going to go down, I have enough data to prove that I'll need some, say, 2 hours or 3 hours of downtime after a month, and that's what's going to help me plan my production better, right? I can use that data to communicate with my supply chain department, planning raw materials, planning finished goods, even planning part inventory, right? So all these impacts in different business modules within of the bottling industry are huge. So of course, the basics is to start with digitalization at the local level. What I see as a future of this is, you wear a smart glass, you look at a motor, and on your screen, augmented reality, you see the health of that motor, right? Now, this is a very informed facility, if you will. Even if a layman's walking down the shop floor with a smart glass on it, you would know that, okay, this motor's health is deteriorating, and the problem with this, or the root cause is this. I have to follow these maintenance practices. So I know most of the participants here must have heard that the knowledge transfer is not that effective, and the subject matter expertise is retiring. The knowledgeable workforce is retiring. So the biggest challenge that we have specifically in the bottling industry is finding great young talents, right? So how I see transforming into digitalization would also help our industry eliminate the skill gap that's required, right? So that's why we need these smart systems to tell us, hey, this is the health, and this is the exact cause why the health is deteriorating, and these are the maintenance practices to be followed. And you have that information not just looking at a computer or a smartphone. You can wear a smart glass and have that information on you. You can order parts with visual commands, and that's how we see the future of this industry.
Great, that's amazing. When you're looking at digitally transforming and implementing this in your organization, how are you approaching and measuring success of that transformation?
So it really boils down to certain benefit stream of having such kind of system, right? So when we say digital transformation, right now we are typically talking about asset health and understanding or predicting failures for critical assets, right? What is the outcome of knowing that my machine's going to fail or my machine's health is going down? So all the tangible benefits that you showed or that we discussed about earlier and all the intangible benefits, the way we measure success is we look at 4 typical benefit streams, which is purely tangible. Number 1 being unplanned downtime. Now, unplanned downtime directly relates to all my bottling folks would know would be number of bottles and number of cases. OEE, which is overall equipment efficiency, or throughput, right? These are like the buzzwords for the performance of your lines, of your machines. So I guess unplanned downtime is the first measurable, tangible impact of the benefit stream, and which is huge, right? This we're talking about high-speed manufacturing, hundreds and thousands of bottles being produced in like hourly basis, right? So unplanned downtime has a huge impact on companies' performance, right? So that's number 1 benefit stream. That's how we measure success. So if we have our current state at, if we have systems in place, which I think to start with in the first place, we should have systems in place to measure the current state. If we don't know how much unplanned downtime we have because of failures on a critical asset, then whatever we improve, we can only improve what we can measure, right? So we should be able to measure what is the current state of our system, right? Along with that, you translate straight that into throughput and dollar value, straight, right? That's success. Second is, of course, premature failures and replacement. So how we can approach that is basically if you're spending too much money and if you're spending too many labor hours and time and resources on fixing a problem repetitively on a single critical asset, then you're doing something wrong, right? So with knowing the asset health and the failure modes and the root cause, what it's going to help us with is avoid premature replacement, premature failures. I'm not sure, like many companies or many industries that I've seen, they have in-house repair shop or workshop where they repair motors and stuff. Some industries, they're like, oh, it's overheating, let's just replace it, right? They don't know when it was replaced last. We don't have any data for it. So I guess, again, the first step to start with is measure the amount of premature replacement that is being done as of right now. And then with these systems, that's how we measure success. On now we know that we are increasing the life cycle of our critical parts, critical assets, which are very expensive, and we are avoiding premature failures and replacements on it. That's 2, right? So the third way to measure success is, of course, if you're not confident when your asset's going to fail or your machine's going to fail, which means you need something in inventory as a backup to make sure that it doesn't fail. So typically we've seen around 15 to 17% of your on-hand inventory parts inventory cost is attributed to motors and related parts. You can easily reduce that and free up that money. That's like basically freeing up capital money, and then that's another way of measuring success. Is the market shows that 15 to 17% of your on-hand inventory is attributed to motors and its related parts. Now you know the health of the motor, you might not need that many in inventory. So I guess these are the 3 major benefit streams, and that's how we should start measuring success from ground level. Of course, with what Lauren said, with other intangible benefits is like employee morale, and having this data connected to different business modules, that's a different level of success. But to begin with, these are the basic streamlined benefit stream that we look at for from digital transformation.
That's amazing. Yeah, I love the specificity and the detail you're able to provide. That was really helpful. The next question actually gets to something that I think that you mentioned before, not to feed you an answer, but you mentioned that there's a skill gap, and there are retiring knowledge centers and people that have had experience with the machines that are maybe not going to be at the plant all that much longer. Plus, just the nature of employability these days, with a lot of churn possibly within engineers and people moving from site to site. Really, when you are approaching your program and the digital machine transformation, who is primarily championing the actual deployment at the site? And if so, is that different than the person who manages the program? How are you sort of approaching that from a champion, maybe at the site level, versus the manager of the program?
So how I see it, it's a strategic partnership between like the corporate and the plant team. So it's a combination of a top-down approach and a bottom-up approach. So it's a sweet spot that should be established with the corporate functions driving reliability within their manufacturing facilities, and the interest from the bottom up, which means the manufacturing facilities actually have interest in these systems. So typically how we've seen success with these programs is, you have an owner from a corporate perspective that owns the program in terms of not just the pilot, but also in terms of rollout and expansion. How can one face from the company that shows the culture of the company in terms of maintenance, in terms of reliability, reliability-centered maintenance. That's like one face from the company that owns the whole program and that drives expansion and rollouts to make this program successful. But of course, having said that, the plant team is the champion of this project, where you have either a maintenance manager or a CI manager or a senior maintenance tech is responsible for managing the entire show from the plant side, because this is not possible without buying from the shop floor. So unless they feel the pain, they understand the pain, and they know that something's going to make their lives easier, they're not going to support on this. So the biggest takeaway that I've had personally is it is very important to create that buy-in at the plant level, which is why it's not always the top-down approach where like corporate teams are saying, you got to do this, and they have to just because. Rather, I'd say it's a more kind of a strategic partnership with the plant team, which really makes sense because they're already bought into the idea of digital transformation.
Great. Yep, absolutely. I think that makes a lot of sense. Last question here, and then we'll move on. But what was your objective? Do you think, if you had to pick one? It sounds like obviously there's a lot of different areas and things that you had as a goal to address with digitizing the machine house. But what was your ultimate objective when you started out on this digital transformation journey?
So for me, we all talk about evolution of our maintenance programs, right? We evolve from reactive maintenance or run to failure strategy to preventative maintenance, right? At some point, we establish a strong preventative maintenance program, a very robust program, and then we ask ourselves, yes, we did improve in performance of our production lines, of our bottling lines, because of having a very strong preventative maintenance program, which I guess everyone on the participant list would agree that the major impact of improvement on your production line is how effective your maintenance program is. So having a very robust preventative maintenance program will get you to a level of high OE, high throughput, high availability, and your machines are running good. But then you ask yourself this question: is it time that we are spending too much money on maintenance? Can we optimize it? Can we find a sweet spot? Can we do maintenance just in time? That's where we start this journey of digital transformation, where we think that there should be a system that tells us, hey, it's time, you should be doing this. So it's similar to your car, right? Previously we had like calendar based maintenance on our cars, like every 6 months change your oil and filter. Then we evolved into mile based, which is like operating hours based PMs, right? Which is mile based, like every 6,000 miles you got to change your oil and filter. 6,000 miles maybe in 6 months, in a year, in 2 years, who knows. And then finally we came up with systems in the car that tells us what is your oil life. It may come at 8,000 miles, 10,000 miles, 15,000 miles, but we trust the system that is going to tell us, hey, you know what, your oil life is 5%. Maybe next week or 2 weeks from now, you should schedule a service for maintenance on your car, right? So I think that's what triggered us as a company, that we have a very robust PM program. How do we take the next step and optimize our maintenance costs, reduce our maintenance costs, labor costs, right, without compromising the performance on our line? So I think that was the biggest trigger for us to start this journey. And of course, there's so many different options in the markets, and there's so many systems that you could work with. But of course, we always start with standard piece of equipment, because as all these folks would know, like installing predictive maintenance system on cams and rollers and critical assemblies and critical components, it's very hard because we don't have the industry data for it. But again, we miss the part which is pretty evident, which is like critical motors and pumps, which is a huge cost to still in our modeling industry, which we miss. So we take step by step, we take this journey of digital transformation, starting with standard piece of equipment throughout any manufacturing industry.
Great. Thank you so much for answering our questions. We'll bring you back in at the end when we do sort of more of the open Q&A, and I'm sure people will have some really good questions for you there. So thank you, Jalay.
Of course. Thank you.
So turning finally, really quickly, just wrapping up some of the things that we've discussed today. We've covered the bottling industry's major pain points, some of its historical approach to maintenance, where we've seen some success in transitioning to a digital machine health. Of course, talked to Jalay about his experience with that journey. And now we're going to move finally to the ever important subject of quantifying that return on investment. So to set the stage, it's important to understand that machine health occurs in increments. There's this deployment period where you're starting to gain some visibility into your machine health. There's the capturing of low-hanging fruit. Some of those more immediate issues are able to be resolved quickly. Then we have this period of time making repairs, tracking impact, to finally move towards the goal, right, this new state of reliability where we see an overall increase in the OE, or operational equipment efficiency. And this process, byproduct, of course, as we talked about, has many benefits, the avoided cost failure, increased asset optimization, increased reliability and performance. But how to start that process and to sort of break those increments into key steps? The first is really to provide the machine health visibility. Second step would be to provide tracking of those activities and avoided failures at the plant level, and then ultimately quantifying that impact, right? So the main first step and the main goal of the first step is to provide visibility and transparency for you into your machine health. Visibility gives access to all levels of the organization. We touched on it a little bit with Jalay. The having that insight and visibility helps you just on a basic level of being more strategic having, again, access to all levels of an organization and providing a real current state of the organization alignment. The second step around tracking is approaching and strategizing about what repairs to make, when do you make them, at what threshold, and then tracking those impacts in a single data system, a single repository that allows the site to be strategic about its machine health management. And then the third and final step is quantifying each of these. So every instance of a repair or some kind of issue should have some rigor around it, some process level where you're looking at the cost avoidance. So in this particular instance, an issue was identified on a critical fan, and it was bearing wear, and a repair was made. So putting down and quantifying into the system exactly all the costs avoided, so very rigorously saying, here was the production downtime, here was the line cost downtime, here was labor cost, possible replacement cost against actual replacement cost. You're able to get an impact number that you can then track and provide to your stakeholders. And of course, that's just one machine and one single point of failure. But when you're looking at it again on a line level, taking that single event and applying it, you can see that mitigating these failures early and often and putting some rigor around it on the back end to quantify the impact really shows the return on investment needed to approve an overall program. And then to take it one step further, it's important to recognize that from a corporate perspective, these savings at the line and then ultimately the plant level have serious cost savings on your entire organization. So when you think about these impacts at a global scale, you can see how machine health would be and should be an embedded part of any organization's digital transformation strategy. Being able to have that visibility, benchmarking across facilities, being able to track KPIs allows your organization to be more strategic, starting with the digital machine health. So how does an organization get started, or how would a bottling organization start to approach digitizing? There's a recipe, really, that we've seen really drive success in this area. Each of these ingredients is crucial for it to be successful. First and foremost is finding a turnkey technological solution to provide that digital machine health. Secondly, and Jalay very aptly touched on this, is really having a dedicated and actively engaged team at the plant level. But in addition to have that actively and engaged plant, you really do need that corporate sponsorship and alignment to drive accountability and provide the support. But having each of these ingredients, again, is the recipe for success ultimately, and the combination of them is very powerful. And once this recipe is in place, you have sort of all the pieces. The way that we've seen organizations transition successfully is through a phased approach. So starting with a single site, learning what machines and processes are critical, beginning to work out the kinks, make sure that people are being held accountable for repairs and the quantification and the tracking, and then expand that to several sites where then the business case truly and the technology itself can be validated and tested to ensure that both those strategies, both the reliability plus the digital strategy, are in place. And finally, taking those lessons learned from that validation in the handful of facilities and applying that across your entire portfolio. So approaching this transition in a phased way, recognizing that it's not all going to be overnight, that it is a journey, helps it to be a little less overwhelming and allows for true buy-in to happen both at the ground level, at the plant level, but also to have the infrastructure in place at the corporate level to support initiatives such as this. Okay, so we're getting towards the end. We definitely want to make sure that we answer some of the questions that are coming in. So let me go ahead and start with the first one. Jalay, this one I'm going to hand over to you. And actually, I think that you addressed it kind of, but it's a little more specific and to the point. But the question is, how do I know which equipment and/or processes to start with when I'm looking at monitoring my machines?
So in the domain of reliability centered maintenance, we are looking at, the first step is to exercise asset criticality, right? So where do you start with? That's a very good question. So what typically needs to be done is we need a tool to understand where our PM is right now, preventative maintenance is right now, right? So we call it preventative maintenance optimization. Every PM task that you have on your standard equipment, or even your flow molders, your fillers, your cappers, your bottle washers, your pasteurizers, I'm pretty sure we all do weekly PMs and bi-weekly PMs and monthlies and quarterlies, right? What we need to do is we need to agitate ourselves and ask these questions for every PM task. Does this add value? How does it add value? Okay, is this something that is addressing the active issues on the line, right? So you have an active issue that's been going on for months, but none of your PM task addresses that active issue. Okay, then is this PM task effective, right? Do I need to add any PM task? A market research shows that there's nearly 20 to 30% PM tasks in your list of PM which are non-value added, right? So I think that's the biggest gateway to find CBM and PDM opportunities, condition-based maintenance and predictive maintenance opportunities. So basically, when you have critical inspection tasks to measure something, right? So I know a lot of times it's just by experience. So I'm touching this motor, it's hot, it's overheating. I see metal shavings. I see the motors rotating very weirdly. It's abnormal. So let's just start looking at it, right? Rather than this, how about having an inspection task? You're not inspecting, it's being continuously monitored, or even with handheld, you're monitoring it, but now you have data. So the basics to start with identifying the opportunities where we can apply predictive maintenance systems or digital transformation starts with a basic question of, are your PMs optimized? Once you answer those questions, you'll find opportunities. Now you have 100 opportunities, but you don't have the bandwidth to work on all the 100 opportunities, right? So now you got to boil it down to critical assets. That's where you come with asset criticality tool that will help you identify the big buck opportunities, meaning biggest impact of downtime, right? So now if you have an option of implementing a predictive maintenance system on a blow molder main drive against a high pressure compressor pump, you would definitely choose high pressure compressor pump because that's going to affect all my production lines. Of course, considering you have more than one production line in the facility, right? So it's not just that. It's not just impact of downtime, but it's more of how expensive is this asset, this machine? Do we have any inventory in spare? What is the lead time to order? Do we have any transportation repercussions if there's any larger downtime, right? Is it safe? Is it accessible, right? These are the questions that goes into a typical asset criticality model that needs to be answered along with subject matter experts. And, that's how you boil down your 100 predictive maintenance opportunities into 50. And then you start with the band, basically depending on the bandwidth you have, you start with that number. So I think that's the way to address this.
Great. Yeah, absolutely. I think that makes a ton of sense. So the next question we have, I'm actually going to take a stab at answering it, and then I would love to hear, Jalay, your impression about it as well. But so this person asked, we've done projects at our sites before, but struggled to get buy-in. How do you get adoption at the plant level? In our experience working with plant levels, this is definitely something that we've heard before and obviously seek to do, and driving adoption is obviously key to having any kind of impact within the organization. But, really I think it starts two ways. Having a really strong champion at the site that is very involved in the day-to-day is incredibly invaluable. I would say secondly, and this gets a little bit back to the recipe that we had previously in the presentation, but it's really having that corporate support and sponsorship. I do think that culture is set at the top, and an organization that emphasizes maintenance optimization and empowers their maintenance teams on site, but also keeps them accountable, I think has been something that we've seen to be really powerful. Even when value is driven at the site, ultimately having that level of backing and sort of support from corporate, I think has been really powerful to use those sort of together. Jaleh, would you say something different, or how do you think that you get adoption at the plant level?
No, I totally agree, and I guess getting adoption at the plant level starts with having the buy-in from the plant level, right? And the only way to do it is what I believe is you have to have a system in place to measure the current state. I'm pretty sure everyone's using CMMS systems and line monitoring, performance monitoring systems and whatnot, right? All you have to do is start collecting data, show the plant how much money are they spending on replacing critical assets, how much downtime have we incurred, how many labor hours have we spent. So typically these are your pain points, right? Every plant wants to succeed, right? Every plant wants to be the best in maintenance and production, right? So it is about them. It's not about us doing a project, or it's not about just because the industry is going into digitalization, let's just start a journey, right? It is addressing active pain points, active issues within the plant team. So again, not to mention that this is not taking someone's job away. It is encouraging them to be more productive and use their time in some greater innovations rather than doing a repetitive task which is non-value added, right? So it is about making them understand that this is for you and this will help in your growth as well, right? So it's a win-win situation for the plant, for the corporate, and for the employee himself.
Yeah, that's great. Yeah, and I think we've struggled in the past with messaging around that, about feeling, oh my gosh, is this replacing me? Is technology and going to be doing my job tomorrow? And it's absolutely not. The data only provides you an ability to optimize what you're doing and not spend your time doing wasteful or possibly less efficient things, right? Last question I have, and actually this is Jaleh for you as well, but it's kind of a fun question, and we'll end on this. But I'm personally curious, what was the biggest thing that surprised you learning, or lesson learned during this journey? What was the thing that you learned and it just was sort of like out of left field, or took you by surprise in some way?
So, okay. So the biggest thing that I learned, now this I might be out of my area here, but so everyone, we all have car insurance and personal health insurance, right? So how do we justify that cost, right? So if you haven't been to a doctor for past 2 years, or like God forbid you haven't been in an accident for past 2 years, how do you justify the premium that we pay for our insurance? Do we say, okay, just because I've not had an accident in past 2 years, or I've never been to a doctor, I'm stopped going to pay for my insurance, right? Because the wonderful thing about life is its unpredictability, right? And that's what we're trying to address here, right? So my biggest learning or takeaway from this is, at times we might, or asset criticality results might not fall in with the current state that we have measured, right? And that's one of my learnings, that I have my records, I have my data, I have my report that tells me these were the 10 machines that were the problem maker in the plant. But when I perform my asset criticality, maybe 5 of those machines will fall under the critical assets, the other 5 might not. So how do I align myself, or how do I align all the stakeholders and higher management on saying that yes, the return on investment is not just based on historical data, but it's also about predicting the future state, right? So we might not have had any incident on these critical assets in the past. We cannot guarantee that this might not happen in future, So
Mhm.
the unpredictability of life is one of the challenges that I've faced in this journey, and I guess we have been pretty successful in addressing that, and get everyone on board on the same page of understanding that yes, this is more of predicting failures for future might not always address what happened in the past.
Gotcha. No, that's great. Um, so with that, I know we're coming up on time. Thank you so much, first and foremost, to Jalay. Thank you for joining us and letting us pepper you with questions. And thank you to everyone who is attending. As Eliza said at the very beginning, we will be providing the recording and the slides for this. And obviously, feel free to reach out to anyone at Augury should you have any additional questions that we didn't address on this. Again, thank you, Jalay.
Thank you. Thank you, guys.